Today I'm going to teach you how to identify whether a given number is a perfect square or not. If it is a square, then how to find its squares without multiplication. So for that, we need to do some recapitulation. A number having a 2, 3, 7 or 8 at a unit place is never a square number. We know that any number whose unit place is occupied by 2, 3, 7 or 8 is not a perfect square. So for a number to be a perfect square, its unit place must be occupied by either 0, 1, 4, 5, 6 or 9. But we have a number like 30, 51, 34, 55, 76 and 99. In this, if you look at this number, their unit place is occupied by a 0, 1, 4, 5, 6 and 9, but these numbers are not a perfect square. Then how can we identify whether a given number is a perfect square or not? But the condition is that without multiplication. So there are so many techniques. The first technique, let's take a 36. I need to prove that this 36 is a perfect square, but I am not allowed to do any kind of multiplication or a division. So for that, what I will do is that I will subtract a odd number, a conjugative odd numbers, but must be start from 1 until and unless either I'll get a 0 or any negative number. If I get a 0 at the last, then we can say that the given number is a perfect square. If I get any number other than 0, then we can say that it's not a perfect square. Let's see. 36 minus first odd number must be start with 1. 36 minus 1 is equals to 35. Now from this 35, I will subtract a second odd number, that is after 1, 3, which is equal to 32. Now from 32, I'll subtract a third odd number, that is 5, is equals to 27. Like that, I'll subtract from after 5, I'll subtract 7, I'll get 20. Then from 20, I'll subtract after 7 will come 9, I'll get 11. Then after 9, I'll get 11. 11 minus 11 is 0. That means I can write 36 is equal to 1, 3 plus 5 plus 7 plus 9 plus 11. That since 36 can be expressed as the sum of conjugative odd natural numbers starting with 1, hence 36 is a perfect square. And for this, question will come like this: express 36 as the sum of 6 odd number. So we'll do like this. First I'll subtract 1, followed by 3, 5, 7, 9, and when I subtract 11, I'll get the answer 0. So 36 can be written as 1 plus 3 plus 5 plus 7 plus 9 plus 11. So in this way we can express 36 as a sum of 6 odd numbers. Let's take another example, 29. We know that 29 minus 1 is equals to 28. 28, then I'll subtract 3, which equals to 28 minus 3 is 25. 25, and then I'll subtract 5, which equals to 20. Now 20 minus 7 is equals to 13. 13 minus 9 is 4, and 4 minus 11 is equals to minus 7. So final answer we got in negative, which equals to minus 7. That means from this observation we can say that 29 is not a perfect square. Since 29 cannot be expressed as a sum of conjugative odd natural numbers starting with 1, hence 29 is not a perfect square. Overall conclusion is that we can identify a given numbers whether it's a perfect square or not without doing a multiplication. Now my next method is adding odd numbers. Observe the following. 1 is equals to 1 can be written as square of 1. So in this one, if I add another odd number, that is 3, 1 plus 3 is equals to 4. 4 can be expressed as a 2 square. Now I will add one more. 1 plus 3 plus 5. That means I am adding one more odd number. 4 plus 3, 8. 8 plus 1 is 9. 9 can be written as a 3 square. Similarly, if I add one more, it's equals to 16. 16 can be written as a 4 square. Similarly, now I'll add one more odd number, so which equals to 25. 25 can be written as 5 square. We can say that a sum of one odd number is 1 square, sum of two odd number is equals to 2 square, sum of three odd number is equals to 3 square, sum of four odd number is equals to 4 square, sum of five odd numbers is equals to 5 square. Similarly, now if we have n numbers of odd number, so we observe that sum of n odd natural number is equals to n square. Let me explain this with the help of an example. Question is, without adding, find the sum. And question is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. So first I will write a question as it is. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. So now I'm not allowed to do a addition. So I will count the numbers of odd number. 1, 2, 3, 4, 5, 6, 7, 8. So here we have n is equals to 8. So its sum is equals to 8. Its sum is equals to 8 square, which is equals to 8 is 64. So answer is 64. So we got the sum without adding. Now next, square of odd numbers as a sum of conjugative numbers. So square of any odd number can be written as a sum of two conjugative numbers. Let me explain you this with the help of an example. Let us consider one odd number, that is a 3. So its square is 3 square, which is equals to 9. So this 9 can be represented as a sum of two conjugative numbers, that is a 4 plus 5. So this can be done with the help of a simple formula. Formula is n1 represent the first conjugative number is equals to n square minus 1 whole divided by 2. Here n is your odd number, and n2 represent your second conjugative number is equals to n square. Only the minus sign will replace by a plus 1 whole divided by 2. So we have a formula for first conjugative number. n1 is equals to n square minus 1 whole divided by 2, and n2 is equals to n square plus 1 whole divided by 2. Here n1 represent your first conjugative number, n2 represent your second conjugative number, and n represent your given odd number. Let's take an example. Express 29 square as the sum of two conjugative integers. Given number is 29 square. The square of 29 is equals to 841. Here n is equals to 29. we'll use the formula for the first number n square minus 1 whole divided by 2. N means 29, so I'll replace the value of n by a 29. So 29 square minus 1 whole divided by 2. 29 square means 841 minus 1 whole divided by 2 is equals to 841 minus 1 is equals to 840 divided by 2, which is equals to 420. Second number is equals to n square plus 1 whole divided by 2. Minus will replace by plus. So this is equals to 29 square plus 1 whole divided by 2, which is equals to 841 plus 1 whole divided by 2, which is equals to 842 divided by 2 is equals to 421. That means now we can express a 29 square of 29 as 420 plus 421. That means now next topic we have is square of numbers with the unit digit 5. Let us consider a number 25, 35, 45 and 55. In this case, you will find a 5 occupied its unit digit. So how can we find the square of this type of number without doing a multiplication? So for that we have a formula. Formula is a 5 whole square plus a inside the bracket a plus 1 hundreds plus 25. The value of a is the number which is in front of 5. In this case I have 2, in this case I have 3, in this case I have 4, in this case I have 5. But now if I take a number 2, 6, okay, if I take a number 2, 6 and 5, so in this case the value of a is equals to 26. So keep this thing in mind. The value of a means the number which is in front of 5, the number which is in front of 5. Let's do it. For example, find the square of 55. So first of all we need to identify the value of a. Given number is 55, here a is 5. From where we'll get the value of a? The number which is in front of 5. We know formula is a 5 whole square is equals to a plus 1 hundreds plus 25. Now we'll put the value. A means 5, so this becomes 55 square is equals to 5. A means 5 plus 1 hundreds plus 25. 55 square is equals to 5 plus 1 is 6, 6 5s are 30, 30 hundreds means 3000 plus 25. So we'll get 55 square is equals to 3025. Let's check whether it's correct or not. So 55 into 55 is equals to 3025. Let's take another example. Find the square of 125. Given number is 125. Here a is 12, the number which is in front of 5. Formula a 5 whole square is equals to a plus 1 hundreds plus 25. A means 12, so a 5 whole square becomes 125 whole square is equals to 12 plus 1 hundreds plus 25. So 125 whole square is equals to 12 plus 1 13 into 12 hundreds means 15600 plus 25. So this is equals to 125 whole square is equals to 15625. Let's check this one also. So 125 into 125 is equals to 15625.